All right, 7.2, we talk about the converse of the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. And we talked about that yesterday. Today we're going to find out how can you tell if a triangle is a right triangle. How do you know if it's right, obtuse, or acute? And that's what we're going to look at doing today. So if a squared plus b squared equals c squared, then triangle ABC is a right triangle. So we have triangle ABC. We don't know if it's a right triangle, so I'm going to put a question mark there. We don't know what that is. But we know that C is the hypotenuse. Okay, and by the way, these are lowercase c's, not capital C. We put a lowercase b over here and a lowercase a over here. So side lengths are in lower cases, and the vertices are capital letters. So if a squared plus b squared equals c squared, then it's a right triangle. So let's take a look. In example 1, it says verify that the triangles are right triangles, or whether the triangles are right triangles. So if you look at the one on the left, we have 6 and 9 and 3 square root of 13. 3 times the square root of 13 is 10.8. Okay, and I typed it in my calculator to find that out because I want to know which side is the biggest side. And the biggest side is 3 square root of 13. So we're going to call that C, and the other sides we'll call A and B. So if this is a right triangle, then a squared plus b squared will equal c squared. So we want to know, does 6 squared plus 9 squared, I'm going to leave a blank here. We're trying to find out, does that equal 3 square root of 13 squared? So 6 squared is 36, 9 squared is 81. So if you take your calculator, 6 squared plus 9 squared, we get 117. And now, on the right side, we do have to use parentheses when you type this in, or else you get the incorrect answer. So you type 3 times the square root of 13 in parentheses, and then you would have to square it. And 3 times the square root of 13 squared is also 117. So these are equal. So since they're equal, is this a right triangle? Yes, because a squared plus b squared equals c squared. You look at the one on the right, the biggest side is 29, so that's C. The other sides are A and B. So does 24 squared plus 16 squared, is that going to equal 29 squared? So if you do 16 squared plus 24 squared, you'll get 832 on the left side. 29 squared is 841. So these are not equal. They do not equal each other. So is this a right triangle? No, it's not a right triangle because a squared plus b squared does not equal c squared. So if it's not true, the triangle is not a right triangle. So that's one way to tell if it's a right triangle. So if you look down here, what if a squared plus b squared does not equal c squared? Right? What if that's not true? Okay, which we found out in that second example it's not. So let's label our triangle A, B, and C. And we have our side lengths. So what if c squared is bigger than a squared plus b squared? So what if we have c squared is greater than a squared plus b squared? So if that's the case, if c squared is bigger than a squared plus b squared, then angle C is obtuse. And triangle ABC is an obtuse triangle if c squared is greater than. Okay, we do the same thing on the right side. What if c squared is less than a squared plus b squared? So c squared is smaller than a squared plus b squared. What that would mean is that angle C is acute. And triangle ABC is an acute triangle. So it makes sense. If c squared is smaller, it's acute. If c squared is greater than a squared plus b squared, it's obtuse. And if c squared is equal to a squared plus b squared, then it is a right triangle. So if we scroll down to example 2. Example 2 says, can segments with lengths 2.8, 3.2, and 4.2 feet form a triangle? If so, would the triangle be acute, right, or obtuse? So again, just a reminder, to find out if this forms a triangle, small plus medium has to be greater than the biggest side length. So 2.8 plus 3.2 has to be bigger than 4.2. Is that true in this case? Yes. So the small plus the medium side is bigger than the biggest side, so it can form a triangle. So now it says, would this triangle be a right triangle? So just to show my work, we know that small plus medium is bigger than the biggest. So now we have to do 2.8 squared plus 3.2 squared. I'm going to leave a blank, and the biggest side goes by itself. So if you do 2.8 squared plus 3.2 squared, the two smaller sides, you square them and add them up, you will get 18.08. If you take 4.2 and you square it, you get 17.64. Okay, and again, this is C over here, and this was a squared plus b squared. So in this case, c squared was smaller than a squared plus b squared, so this would form an acute triangle. It'd be acute because c squared is smaller. All right, so it forms a triangle, and the triangle it's going to form is going to be an acute triangle. And then in this box, we just kind of talk about what we just summarized. Theorem 7.2 says that if, change to a highlighter, c squared equals a squared plus b squared, the triangle is a right triangle. If c squared is less than a squared plus b squared, the triangle is acute. And if c squared is greater than a squared plus b squared, then the triangle is obtuse. So we have right, acute, obtuse. And so the checkpoint says, in exercise 1 and 2, tell whether the triangle is a right triangle. And then let's actually talk about what it would be if it's not a right triangle. So in this one, the biggest side, we got to find out, what is 2 square root of 10? 2 times the square root of 10 is 6.3-ish. So this is the biggest side. The other sides are A and B. So let's see, 4 squared plus 5 squared, leave a blank, and then 2 square root of 10 squared. 4 squared plus 5 squared is 41. 2 times the square root of 10. If we do 2 times the square root of 10, we will get 6.3245, and then we square that, we will get 40. So these are not equal. 41 is actually bigger than 40. So the answer is it a right triangle? No. And if we look at this, the C part, C is the 40, the C part is smaller. So if the c squared is smaller, this would actually be an acute triangle. So I just said tell whether it's a right triangle. It's not. It would actually be acute. And example 2, the biggest side is 3 times square root of 61. The other side is our a and b. So if we do a squared plus b squared would be 18 squared plus 15 squared. Leave a blank. And on the other side we have 3 square root of 61 squared. 18 squared plus 15 squared will give us 549. 3 times the square root of 61 would be 23.4307, and it keeps going. And then we square that, which would be 549. So these are equal. So is this a right triangle? Yes. It's a right triangle because a squared plus b squared does equal c squared. Okay, example 3 or checkpoint 3. Can segments with lengths of 6.1, 9.4, and 11.3 form a triangle? If so, would the triangle be acute, right, or obtuse? So first, let's find out. Can it form a triangle? You add up the two smaller sides, so 6.1 plus 9.4. And we want to find out that should be bigger than 11.3. We end up with 15.5 is greater than 11.3. So this answer is yes. It does form a triangle because the two smaller sides added up to more than the biggest side. Now, what kind of triangle is this? Remember, we do Pythagorean theorem, 6.1 squared plus 9.4 squared. I'm going to leave a blank, and I'm going to put 11.3 squared. Okay, the C part always goes alone. So take the first two, 6.1 squared plus 9.4 squared will give you 125.57. 11.3 squared will give you 127.69. So if you look at this, the c squared part is on the right. The a squared plus b squared was on the left. So the c squared part is bigger. Right? We're focused on c, that's bigger. If c squared is bigger, that would make the triangle obtuse. Again, we're looking at the c squared part, so that would be obtuse. And then number 4 says, can you use a triangle with side lengths of 50 inches, 120 inches, and 130 inches to form a triangle? Could you use a triangle with side lengths 50, 120, and 130 to verify that you have perpendicular lines? Explain. So this adds one extra little concept. Perpendicular lines would mean it's a right angle. So basically, could we use those three side lengths to form a right triangle? So first, let's check 50 plus 120 is greater than 130. Okay, that's true. So now we have to do 50 squared plus 120 squared. I'm leaving a blank, and I'm going to put 130 squared. 50 squared plus 120 squared is 16,900. And you get that from a calculator. 130 squared is 16,900 as well. So these are equal. So if they're equal, this would form a right triangle, which would mean, does it form perpendicular lines? Yes. So I'm going to say right triangle, so it would, or it does, form perpendicular lines. All right, so we learned today that if a squared plus b squared equals c squared, it is a right triangle. If c squared is smaller than a squared plus b squared, it is acute. And if c squared is bigger than a squared plus b squared, it is obtuse. All right? And that's all we got for today. I will see you all in class.